This is the section I've called loans and credit cards. It's bits and pieces from sections 8.6, 8.7, and 8.8. So first, we're going to talk about two kinds of loans in particular, car loans and mortgages. These are both examples of what we call a fixed installment loan. And these are loans that are paid off by making regular monthly payment over a set amount of time. These loans are, in a way, the opposite of an annuity. With an annuity, we are depositing money regularly and we are earning the interest on those deposits. Okay? And that means that the amount of interest earned increases with every single compounding period because the principal is higher, because we put more money in. With a loan, you are instead reducing the quote-unquote principal every month, which means that the amount of interest charged decreases with every compounding period. Because of this relationship, you will notice some similarities between the annuity formulas we used previously and the formula we use to calculate payments on loans. We will round to the nearest dollar unless told otherwise. So, the loan payment formula for fixed installment loan, your payment is your payment, how much you're paying every month, times the rate divided by the number of installment periods. And since these are loans, your N is going to be 12 unless told otherwise. 1 minus, in parentheses, 1 plus R over N to the negative NT. Now, if you compare that to this formula right here, you can see the A and the P are sort of in different spots. We still have this R over N business. From here to here, the subtraction is reversed. And this is a negative exponent instead of a positive. But I think you can see just by glancing at them that these are related. Okay? So, let's work a few problems. Suppose that you borrow $30,000 for 4 years at 8% for the purchase of a car. Find the monthly payments and the total interest for the loan. Okay, so organizing my information. I'm borrowing $30,000 for 4 years, so that is our P value is 30,000. Our R value is 8%, so 0.08. These are monthly payments, so our N is 12. For 4 years, so T is 4. And I think we have all the information we need here. Okay, so payment is equal to P times R over N, so 30,000, times 0.08 over 12, over, these outer brackets don't really need to be there. They've put them there to make it clear that the whole thing is under the fraction bar. But if you can keep that straight, you don't need those brackets on the outside. To the negative 12 times 4. And then this is just a matter of plugging into your calculators. When I was working through these problems, I ended up using the memory function a whole lot because if you look here, we have the same number right here and here. So 0.08 divided by 12 gives me that. It's an ugly decimal, and I don't want to have to write it down. I don't want to use an approximation in my calculations. So I'm just going to put it in memory on these calculators. You hit STO for store. It's going to put the arrow there, and then your variable button is just above that, X. So we're going to take that answer and store it in X. And now if I just type in the X again, it brings up the same value. So what that means is I can type this a little bit more easily. This will be 30,000 times X, because that's my X, over 1 minus, open parentheses, 1 plus, this is the same value as here, so I'm X. And this is raised to the negative 12 times 4. So we get 732.3876, so on. Now we are asked to round to the nearest dollar unless we're told otherwise. So this is approximately equal to, that's a 3, so 732. So you are going to be paying $732 a month. Okay, so how much do you end up making on interest? Well, if I have $732 a month for 12 months in a year for 4 years, then I have paid in a total amount of $35,136. So that's how much I've made in payments. I'm going to subtract off the $30,000, and the rest of this will be interest. So you're paying $5,136 in interest on this loan. Okay. Now, suppose that you decide to borrow $40,000 for a new car. You can select, sorry about that. You can select one of the following loans, each requiring regular monthly payments. So, first of all, we are borrowing $40,000 and we're making monthly payments. Therefore, our P is going to be $40,000 no matter what. And our N is 12 for both of these. What does change is how long we have the loan for and the percentage. We're supposed to find the monthly payment for each of these and then compare them. Okay? So, our payment formula for, I'm going to do loan A. Our payment is equal to $40,000 times R over N. Well, R is going to be 0.061 over 12. And this is all over 1 minus 1 plus this thing raised to the negative 12 times t, and t is going to be 3. And again, I do this by putting this in memory, so I don't have to type it in over and over again. So I'm storing that in the x value. Now I'll enter 40,000 x over 1 minus, open parentheses, 1 plus x, close, raised to the negative 12 times 3. And you get 1,218.69. So we're supposed to round to the nearest whole dollar, so 1219, sorry. Okay, now for part B. Our payment is still 40,000 times our R is 7.2%, so 0.072 over 12. And this is over 1 minus 1 plus this same thing, raised to the negative 12 times 5. I know what I did. I used a minus sign there instead of a negative. All right, so the rounded to the nearest whole dollar, this will be 796. Okay, so we know the payment on each of these. We're also asked to find the total interest on both of these. So here, if I'm paying $12.19 for 12 months a year for a total of 3 years, then you get $43,884. If we subtract off the $40,000 that we were financing, you get the interest of $3,884. Okay, and they do the same thing here. If I'm paying $796 and I'm paying for 12 months out of a year for a total of 5 years, you get $47,760. Okay, and then you subtract off the $40,000 that we were financing. And so the interest you pay on this loan is $7,760. And then we're asked, part C is to compare these. Well, for part A, you're going to be paying more every month, but you save money on interest. Here you're paying less every month, but you end up paying more on interest. Often you're going to have to make decisions between these kinds of loans.